Hello, my name is Karissa Cordero, and I am a PhD candidate in the Earth and Environmental Science Department. Today, I'm going to be discussing luminescence dating of Mara eruptions in the Clear Lake volcanic field. First, a little bit about Clear Lake and what exactly is a Mara eruption. The Clear Lake volcanic field is an active volcanic area with a long eruptive history spanning about 2.1 million years. The youngest eruptive period is characterized by a series of Mara eruptions surrounding Clear Lake itself. A Mara eruption is a steam-driven event that occurs when magma interacts with surface or groundwater. In this case, the water source will be Clear Lake itself, and when the magma rises and interacts with the water flashes to steam and the magma undergoes fragmentation, producing violent explosive activity. We dated these Mara eruptions using a technique called luminescence dating. Luminescence dating works by determining the last time grains or rocks were exposed to a significant amount of light or heat. In this case, we would be focused on the heat aspect. As grains are laying on Earth's surface, they are bombarded by cosmic radiation that produces crystal lattice defects that can trap electrons. These electrons stay trapped unless they are exposed to light or heat, which can provide the necessary energy needed for them to escape. These electrons accumulate over time, and we can then collect them and stimulate them out in our lab. These emitted electrons produce a light that we refer to as a luminescent signal. Using irradiation experiments in the lab, we can determine the last time they were exposed to light or heat. Luminescence is often compared to a rechargeable battery in terms of its ability for the signal to accumulate, deplete, and then to grow again. The reason we care about dating these Mara eruptions is that Clear Lake is a heavily populated area, so the volcanic field is monitored in terms of volcanic threat assessments. We know there's been activity in the last 40,000 years in this area, but when we talk about threat monitoring, one of the key factors is there activity within the last 5,000 years? If there is activity in that time frame, the associated threat level increases per the USGS. There's reason to believe that there was activity in this time frame due to the stories from the indigenous tribes in the area, where they talk about the mountains having a big fight and that they threw fiery rocks at each other, loosely translating to there being volcanic activity in the area recent enough to be witnessed by humans. So I show you this photo of the local grocery store, and behind it is one of the Mara deposits sampled for the study, just so you can see the scale of these events and how devastating to the area they would be if they were to become active again. Our field site is going to be the surroundings of Clear Lake itself, which currently has 11 mapped Mara craters. One of the first things we do when we talk about luminescent samples is we have to determine which mineral to target and which luminescence protocol to use, as there are many. The common minerals are going to be K, feldspar, and quartz, and the hope is to be able to utilize both as independent age checks. However, this is not always possible, but it is hopeful as both minerals have distinctive optical and thermal properties. We want protocol results that are consistent throughout the samples and have distinguishable signals. In panel A, this is going to be the result of our K feldspar samples. And what we see here is when the samples are subjected to increasing radiation, the signal does grow with dose, which is a good sign in terms of K feldspar luminescence properties, and is eventually the signal we chose to pursue. In panels B and C, we see the result of some of our testing for quartz. Quartz is notoriously difficult in terms of luminescence dating in volcanic environments, as the thermal traps are not stable. What we ended up concluding from this portion of the study is that quartz was not going to be a suitable technique moving forward, as the signals are not isolating the right dosimetric traps. Therefore, we only pursued K feldspar luminescence dating going forward. In our results, I have Clear Lake itself with the mapped Mara craters and the locations of all of our luminescence samples in yellow. There are corresponding radiocarbons in green coming from a past study done in 2022. We currently have ages for 11 samples. 3 are in good agreement with what we call the trusted radiocarbons. These are the ones we suspect limited to no contamination of modern carbon. We do see disagreement in the rest, but most of these radiocarbons are suspected to be contaminated by modern carbon, biasing their ages younger. So this is to be expected, and it is what we see in our results. This is also supported by our panel C, where we have our C13 isotope ratios, which shows that the carbon source is consistent with C3 plant pathways instead of magmatic or volcanic carbon. The exception is going to be one radiocarbon age, which is older than our luminescence age, and this is believed to be due to a methane seep in that area of the lake, producing older carbon, which would then bias the age older. So overall, we see good agreement in our luminescence signals and our luminescence ages between those and the trusted radiocarbons. We currently have not dated any deposits that are younger than that 5,000-year marker, warranting an increase in threat assessment, and all ages obtained are consistent with the last eruptive cycle in the Clear Lake volcanic field. Lastly, dating these eruptions is a critical step in assessing volcanic hazards in the region and mitigating any future risks.